welcome to Desk of Lady Ada.
Hello everybody. We're doing a little late night streaming here, early morning streaming. We spent a lot of today organizing the Desk of Lady Ada room, also known as the bedroom, to make it even better because we're going to be doing a bunch of streaming this summer. And so it's our little test. We've got a new lens.
Yeah, this is a microscope. Yes,
and behind me is the new microscope that I put together. And thought we would test this lens. It's actually much farther away, which is cool. I didn't used to be able to walk from my computer desk to my EE desk. It used to be kind of blocked off, but now, thanks to Mr. Lady Ada's intrepid organizational skills, which must be seen to be believed, there's a path, so I'll be able to do more electronics, not just coding and layout, but then soldering. And debugging.
Why don't you walk over to the microscope and start doing some stuff?
Okay, I'm going to do that. I'm walking.
Yeah. Now we're going to go right now.
Over here.
Yeah, you're fine.
Oh my goodness. So here I am. And this is the microscope that I put together. I actually got two different models. And these come from Shenzhen, and Bunny and Naomi helped me pick out a good one. And this is a little HDMI camera, and this is an HDMI cable. So what you're seeing behind me is actually live video. And before we had a USB and HDMI microscope, and those were really good looking. But the problem is that I couldn't look in at the same time, and so it was really hard to solder. Soldering when you have to have your hands out and there's a microscope, it's really challenging to get things aligned, and also there's a little bit of a delay in the video signal, and so you don't get this instant brain feedback with that you do with a true optical microscope.
Yeah, so I got one now.
Yeah, this is cool because it's trinocular. There's two eyes. And this gives us 7 to 90 time magnification. And then in here, this is another optical path. So the HDMI is seeing pretty much what I'm seeing. The vision actually from the microscope is way better than the HDMI. I'm not sure why. Maybe it's just the way the lens path works. Or maybe because this is mirrored through a couple times. And then you can tune and magnify, so I can zoom in for more magnification. But then I have to adjust the focal distance. So, for example, here we go. You can really...
Hi, Kip.
Hi, Kip. So you can zoom in on, you want to see what this chip is. This is the List 3DH. And, the three... I kind of like this. It's like a tree. This is the AP 21123.3. Anyway, so I thought I'd take a little tour of the Circuit Playground Express, which we released on Wednesday. These are the final designs, and do that with this microscope, and that would be a good way for us to test.
Yeah, so far everything's working.
Yeah, everything's working.
Yeah.
But this is really neat because what I'm going to do is I can see there's a little video camera, but I'll actually tune in, and then I'll use my handy-dandy microscopes to point things out. So, yeah, this is cool. Okay, so starting from the top, here, there's my, see, it's funny, it's my tweezers look really sharp until you see them on the microscope and they're kind of bent and dirty. This is the micro USB, and this is that 8-pin SPI flash. Here is the D13 LED, so let's zoom in. Let's practice our zoom in. There you go, so you can see the little dye element, and then bonding wire, and then matching resistor. As you zoom in, you do have to tweak the focal distance quite a bit. You can see the resistor unmarked. Usually I like them marked, but this one came unmarked. And then the solder fillet, nice fillet. This is the one of the NeoPixels. This is really nice. You can see the, I think this is green, red, blue. Red is definitely a reddish color. Remember, I think this is the blue one. This is the green one. There's a slight tint. And this is the die. You can see the drivers, the chip, shift register, good stuff. So let's zoom back out. And refocus. This is the Atmel chip. Let's see if we can get the, yeah, the printing looks a lot nicer now. The Atmel chip. And I've got a ring light that I can adjust to, which can change the contrast a little bit. Kind of tough to tell if it really helps that much. Like that. That's pretty good. Reset button. Squish it. Hey, reset button. This is the transmitter LED. You can actually kind of see the lensing. You can see the dye through the lens just a little bit. So let's zoom in again. Practice our zoom. It's hard to focus in on it. I can focus it on the bonding wire. It's hard to actually focus in on the dye, but you can sort of see it in there, the large blue chunk. So that's why you can put an amp through these IR LEDs. This is an IR transmitter LED with the nice lens, and you can actually see the ring light in the reflection. But this lens gives it like a nice 15-20 degree directionality, which is really good. It means that more of the photons go in the direction you want them to go. So that's really good. Check out that fillet. Nice fillet. And then over on the other side, this is the accelerometer. Let's zoom in on that texture. You can see the lasered texture, kind of cool. And then this
How much did that scope cost?
This microscope was a couple $100.
Yeah.
I think it was $300 or $400.
Not so bad.
I think the camera was another like $150. This is a 14 megapixel HDMI camera. It's kind of nice. It gives us what, like a 1080p out, I think.
Yeah.
Or like almost, it's like 960p. It's like not 720, not. So you can
It's a pretty
see,
good image.
yeah, you can see I kind of was scratching this up because I was trying to see like what was on top of this. So I was kind of scratching it, but you can maybe if I scratch in my fingernail. One thing to watch out for when you have a microscope is don't look at your fingernails underneath the microscope because it's like super gross and you'll just want to die.
Oh yeah.
Yeah. So here you can kind of see barely underneath this blue.
I want to look at my fingernail.
Well, your fingernails are probably like super clean.
Think you're okay? I wash my hands a lot.
You go over here. It's not in focus. You want me to focus it?
Yeah. See, let's see how. Am I clean or am I dirty? That's not so bad. Oh, that's pretty bad.
Ah, see?
That's so gross.
It's
I just pet the
so
cat.
gross.
I just pet the cat.
Look at that.
That's MOSFET.
Yes.
Hey, MOSFET. Okay.
Yeah, see?
I'm out of here.
Later. But back to these beautiful electronics. So you can see...
I'm terrified.
yeah, you should be. You can see up here the little, like the path underneath the blue lens, and then there's another big die here. This is the pin diode that's used with this chip. This is the VSOP 3838. So what's cool is like, because I have, what's kind of interesting is when you have a really good microscope, your senses become magnified. So like normally I wouldn't be able to feel, like you can't really tell the engraving. But because I know what to look for, I can I can feel and follow the engraving.
Yeah. You have super senses.
Yeah, your brain immediately is like, oh, you have great vision, and it automatically compensates for that.
Yeah.
This is the switch, and the actuator is so tall you can kind of zoom up to the actuator or down to the body or then down to the fillet. So let's practice doing that. So that's the fillet, and then focus up. And then back down. And then power regulator, gigantic switch, more neopixels. This is the speaker driver. Really nice fillets here.
Yeah.
I'm kind of digging this, like you can tell.
I'd say look over to the right to make sure you're always in focus.
Yeah.
Yeah.
I mean, there's actually a focusing knob up here. To make the camera focus the same as the person, there's a little like knob, and I don't want to touch it because like I spent like 10 minutes like tweaking it because you have to have this has a little lens on it too to match the optical lenses here, and you have to like perfectly balance it. Let's look at a gold pad. So this is the Enig coating that we use. So you can see that it's like a gold layering. This looks pretty good. There's some just some flux. You know, there's flux in the oven, so there's going to be little fluxes, little solder balls, little microscopic solder balls. And there's a fiducial. That's nice. This is a fuse. Looks like from here, this is the fuse. Looks like maybe needed a little bit more melting. This is a little soft. We use Grow Haas solder, so you have to be kind of like picky with the temperature. Looks pretty good, but like this could be like a little bit more melted maybe. All right, well, that's my tour.
Yeah, I want you to get ready.
Yeah.
We're gonna put a cat paw underneath this. This is the first time this has ever happened on the internet.
No.
Okay, do it.
Okay, well it's all black.
Yeah, but
You can't see anything.
we'll edge it out. There you go.
Yeah, see, this is me. No, I mean he's just black.
Yeah, but you can focus it in.
No, I can't because it's all black.
Yeah, but there's like a cat paw. Like if we there
Okay,
you go.
hold on,
Look.
Okay, hold on.
It's a live cat paw. Now you gotta back out. That's MOSFET.
Yeah.
Hair.
Yeah.
Yeah, she has gray hair like me.
Like his paw pads?
Yeah, alright. That's good enough.
Okay, good. Sorry.
Hard to put a cat under the microscope.
That's my skin.
Okay. Alright, well that's it. We'll
Whoa, skin's weird.
oh, you're gonna get hacked. You're gonna hack your fingerprints.
No, it's the top of my hand.
You're gonna totally like they can get into your MacBook Pro now. Alright.
And then you zoom out and then you're like, okay, you can actually see some more. So then let me go to the board. So yeah, we zoomed in, but this is it not as zoomed. So let's zoom in one more time to the QFN pads. So those are some nice QFN pads. Look at that. Nice. Nub 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 nub. Nub 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 nub.
Enhance.
I've enhanced as much as I can.
Alright, well we'll do something tomorrow, but let's get out of here.
Yeah, we're done.
Like 2 in the morning.
Yes. Nub 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 nub. Okay, that's it. That's all I got.
Okay. Bye everybody.
Bye.